Hello and welcome to this quick demonstration on modeling a bulbous bow to an existing bare hull surface. My name is Heinrich, I'm with Friendship Systems. This demonstration is based on a feature definition that allows to choose an existing surface and on that surface an isoperimetric curve, which is then mapped onto any spatial target curve while the underlying surface follows along. We are looking at a fully parametric model here, a surface model which so far features a simple box gag but no bulbous bow. The majority of the forebody of this hull model consists of one single surface, so the first step of this demonstration will be splitting that surface into subsurfaces so that we have our initial surface, which we then can turn into the bulbous bow later on. So I'm positioning manually those control points here in the 3D window and connect them with a B-spline curve, which I will then in the next step project onto my initial surface of the forebody here. That projection curve then serves as the basis of a subsurface which will be the starting point for the bulbous bow modeling. By simply copying that subsurface surface and swapping the index here, I can make sure that I also have surfaces that cover the remainder of the initial forebody. Just for convenience here, creating image surfaces of the two subsurfaces that I can easily copy and paste the formatting options of the initial surfaces here. Just tuck away whatever is not needed anymore, and then copy the format here, increase the display resolution a little bit so that we get a smooth visual of what is going on here. I've highlighted the part that is most interesting for the upcoming steps here in green, and now comes the interesting part. This feature definition is what I've quickly described in the introduction to this video. Basically, it allows to choose an isoperimetric curve and then map that onto any target curve that is given in space. So I've set tangency constraints to the two ends here so that I will match the initial edge of the surface at the ends. But then in between, I'm free to move those three control points here to create the contour or the outline of the bulbous bow that I would like to have later on. So that initial green surface now has been morphed, so to say, to that new surface. And if I mirror that here and then look from the top, you can see this is still way too sharp at the waterline entry. So what we're going to do is basically just the exact same thing one more time, only that this time we're not mapping the initial edge of a surface, but an isoperimetric curve at 0.5 in this case, so somewhere along the maximum thickness position of the bulbous bow. We're not constraining the tangent at the forward end of the bulbous bow here, and then by detaching this feature, we are able to manually drag those control points in 3D space and establish the maximum thickness contour of the final bulbous bow here. I'm doing this in two different planes to ensure that the curve looks nice and smooth while I'm hiding the surfaces. And then when I turn them back on, you can see that. And now we already have something that looks quite decent here. Again, I'm increasing the display resolution here just to make sure that I get a better visual on the smoothness of the buttocks and sections that are shown in 3D view here. The feature that was used to create those surfaces also created this design variable called mapping factor, which allows to set the amount by which the target contours are actually matched. So if I reduce this factor here, you can see that we can now choose anything in between the initial bare hull to a bulbous bow that perfectly matches the two target contours that we have drawn in 3D space. Looking from the side here at the control point of the thickness distribution, you can see that by dragging those points around, again, I have very good control over the shape of the actual surface, while it stays smooth for anything reasonable, for any reasonable location you would want those points to be in. As a next step now, I am copying the entire working folder that we have been working on so far, just to have a second version of a bulbous bow here that I will quickly sketch up for you so that you get an idea what else is possible. By finding the point that was used to establish the tangency towards the stem contour here for the initial bulb and dragging that up, you can see that immediately we get an entirely different topology here for the surface. So just moving those 2 points to reasonable locations, and you can already see that we now have a bulbous bow that features a distinct sharp knuckle line here at the transition towards the remainder of the forebody. For comparison, I'll just quickly bring in here the smooth version of the bulbous bow. If we look at the transition towards the remainder of the forebody here, if I just quickly turn that surface to the same color as the remainder, you can see that there is barely any transition visible. So this is really a very smooth surface that was attached here in a very simple means. Thank you very much for tuning in. And please keep in mind that the approach shown in this video is, of course, only one of the many, many ways to go after a task like this. I hope you could appreciate the ideas shown in this video, and please stay tuned for the next one coming up.